Alright, this is Mr. Gillen. Today we're doing lesson 2.3. We're going to talk about slope and rate of change. When we talk about slope, for the rest of the chapter, and for most of the rest of the year, we're going to refer to the slope as m, the variable m, as slope. And this lesson specifically, we're going to talk about slope as two different ways. The first way is rise over run. The second way, this whole mess over here. Rise over run, and y2 minus y1 over x2 minus x1. Okay, these are the two things we really got to know for this lesson specifically. Okay, if you get a word problem, slope is generally referred to as the rate of change. Rate of change. Okay, so let's take a look here. Okay, find the slope given the 2 points. Now, the very first slide says it was rise over run, the slope is, or you can use this little formula here, and it says m, that stands for slope, equals y2 minus y1 over x2 minus x1. Now from yesterday, you should know our coordinates are in the form x comma y. Always x comes first, y comes second. In this formula over here, in this little method to find slope, there's these numbers, 2 and 1 and 2 and 1 on the top and the bottom. They are subscripts. That helps you keep track of which y you're talking about. They're not numbers that you multiply, they're just keeping track of which y we're talking about. So on my 2 points here, I'm going to label them x and y, x and y. And let's talk about where I can find a y2, y1, x2, and x1. Because there's two x's and you can't really tell the difference between x's, and there's two y's and you can't really tell the difference as they are right now, we need to figure out, we're going to call this one point 1 and this guy point 2. So my x in my point 1 is going to be called x sub 1, and my y in the first point is going to be y sub 1, and similarly x sub 2 and y sub 2. So now in my formula here, okay, I have numbers to plug in for my variables. I know the slope should equal y2, 4, minus y1, 2. I'm going to go ahead and plug everything in parentheses. And on the bottom I have x2, which is 3, minus x1, 1. This method of finding slope only works when you are given 2 points. So when you're given 2 points, you need to use this method to find the slope. So I'm going to do a little simplifying. M equals 4 minus 2 is 2. 3 minus 1 is 2. I know that the slope m must be equal to 2 divided by 2 is 1. Okay. Only improper fractions today. Do not change to mixed numbers or decimals. Only improper fractions. The slope is 1. So there's our first example. Now let's just see what happens here. We'll go a little quicker on this next one. We're given 2 points. And I remember that slope is the variable m. And we know the slope is y2 minus y1 over x2 minus x1. I have 2 points, point 1 and point 2, and I need to make sure I know that I can keep my variables separate. This is the x coordinate in 1 and the y coordinate of point 1, and this is the x and y coordinate of 2. So once again, this method of finding slope is used whenever you have 2 points. I'm going to do a little substitution now. The slope, m, equals y2 is 1 minus y1 is 5 divided by x2, 2 minus x1, 3. Once I have all my numbers plugged in, I just need to simplify. The slope must equal 1 minus 5 is negative 4 over 2 minus 3 is negative 1. I know I can simplify that. Negative 4 divided by negative 1 is 4. My slope is 4. M equals 4. Okay, so let's do a few more examples. We'll go a little quicker this time. We have the point -5, 1 and 3, 1. Once again, we're given 2 points, and we know that to find the slope given 2 points, our equation would be m equals y2 minus y1 over x2 minus x1. Once again, those are just subscripts. They do not get multiplied into anything. My first point, I have an x and a y, and since this is my first point, I'm going to say those are x1 and y1. My second point, x2 and y2. Now, I'm going to be very careful to plug my numbers in with parentheses this time because this negative could cause some problems if I don't. So here we go. We're going to say m equals y2, 1 minus y1, 1 over x2, 3 minus x1, -5. I'm going to do a little simplifying here. M equals 0 over 3 minus -5, if I do a change, is 8. But as soon as I get that 0 in the numerator, I know 0 divided by anything is 0. So I know my slope is 0. This would be a 0 slope. M equals 0. Okay? Now, I can't stress the importance enough of plugging your numbers in parentheses, especially when you get these negatives in there. Okay? So let's just move on to another one here. Let's take a look at -6, 0 to -4. We're going a little quicker this time. Slope equals y2 minus y1, x2 minus x1. Label my variables. I'm going to say the slope is equal to -4 over change, 2 plus 6 is 8. I know that -4 and 8 both have a 4 in common, so I'm going to cross out the 4 and put a 1, cross out the 8 and put a 2. I know my slope must be equal to -1/2. Okay, so we went through that one a little quicker. I may refer to slope as the change in y over the change in x, because as you can see, this calculates the change in y, this calculates the change in x. So if you hear me say that, that's what I'm talking about. The change in y over the change in x. That's the same, that's what slope is. Okay? So here we go. Let's do another one. We had the points -1, 3 and 5, 8. I'm not even going to write the formula up there. I know it's x1, y1, x2, y2. I'm going to say the slope must be equal to y2, which is 8, minus y1, which is 3, over x2, 5, minus x1, -1. Now you see how important those parentheses are on the bottom. The slope must be equal to 5 over 5 minus -1 is the same as 5 plus 1, 6. My slope must be 5, 6. Okay, there's another example for you. Again, let's take a look here. This is an interesting example. Once again, label my variables here. And something special happens on this one. We'll just say the slope equals y2, -1, minus y1, 6, over x2, 4, minus x1, 4. Now look what happens. On the top, do a little change, -1 plus -6 is -7. And then on the bottom, we have 0. Now this is special because we don't know how many times 0 can go into -7. It could go in once, twice, 3 times. Okay, it's not a definite number. So what we're going to call this is an undefined slope. The slope is undefined. Okay, so if you get 0 in the denominator, you have an undefined slope. If you get 0 in the numerator or on top, you have a 0 slope. And that's what I want to talk about right now. I want to talk about if 0 is in the numerator, okay, when you do your change of y, if you get a 0 on top, it's a 0 slope. If the slope has a 0 on the bottom, okay, if the change in x has a 0, the slope is undefined. So if we were to graph some types of slopes, here's what they would look like. A positive slope. Just like you're reading a book, you read from left to right, you read a graph from left to right. From left to right, I notice that my slope is increasing, so I'm going to call that a positive slope. Reading this graph from left to right, I notice that it's going down. That is a negative slope. Okay. Finally, these are the ones that are hard to keep track of. This guy right here is a zero slope on the left. As you can see, there it just is a horizontal line right here. That's called zero slope. And finally, undefined slope, which is straight up and down. Okay, that's undefined. Now, the way some of my students in the past have remembered zero slope is that you can just write zero slope right on the line. On the undefined, you can't write undefined on the line. Okay, it kind of rhymes. You can't write undefined on the line. Undefined on the line. You cannot write undefined on the line. So that's a way to remember your types of slope. Okay.